Hi everyone, my name is Deepak Kumar and I am a physics faculty for JEE Mains and Advanced. Okay, so in the last class I had discussed about one very important topic that is called work energy theorem. Okay, so today I have taken some problem based on that theorem itself. Okay, and today we will discuss those problems. So I have one request. Okay, those person who are looking at this video for the first time, okay, I will suggest please go to my previous video. There I had discussed about the theory of this theorem. Okay, so it will help you to understand these questions itself. Okay, so without doing any delay, let me start the discussion of these problems. Okay, I have taken note very difficult one, some easy problem to understand the theory of this work energy theorem itself. Okay, so let's start the discussion. Okay, so first question I had taken, find the constant force needed to accelerate a van of mass 1000 kg from rest. Okay, remember from where we are taking this van, from rest to a speed of 36 kilometer per hour. Okay, remember the unit here I have given kilometer per hour after traveling a distance of how much, 100 meter we can say. So let's start solving this problem here. Okay, so just one second. So how we are going to discuss? Okay, look, in the work energy theorem most of the question how it will come. Okay, in this kind of question they may ask you find the force, sometimes they may ask you find the displacement. Okay, but most important thing in this kind of question it will be there. Okay, initial velocity or final velocity information will be given. Okay, using those 2 points. Okay, using those 2 points in any question you can identify can you solve this question using the work energy theorem or not. So in this case you can see in this question. Okay, so here initial velocity, which was initially the van was at rest and later time it started moving with what speed, 36 kilometer per hour. After after traveling how much distance, that is 36. Okay, that is how much given, 100 meter itself. So think about this is the road I'm taking. Okay, on that road what happened, one van is there. Okay, some van you can imagine. Okay, this is the, okay, just imagine that this is a rectangular, just imagination purpose. So here this van was on the road and some force has been applied. Result of that what happened, this van has just started moving. Initial velocity, it is information is given. Okay, it is information is given how much. Okay, initial velocity was 0. Okay, v initial, and later time this van when it has moved in the some distance right side, and that distance is also given how much here. Okay, if you will see this distance from here to here, the total distance is given 100 meter we can say. So they have asked you, okay, how much force will be needed to accelerate this van from 0 to 36 kilometer per hour, 36 kilometer per hour. Okay, so it is given in hours. So first what we can say, everything we are going to discuss in SI units. So first we are going to convert this kilometer per hour to meter per second, and already you know the formula, isn't it? 36 into 5 by 18 we can write. 18 2 times it will cancel out, it will come how much, 10 meter per second. So final velocity how much become, after traveling 100 meter it become 10 meter per second. So you can see initial velocity is given, final velocity is given. So they have asked this constant force, force is constant. So we can use here work energy theorem. So what does it say, work done by all the forces. Okay, sum of work done by all the forces, okay, will be equals to how much, change in kinetic energy. Change in kinetic energy, that is also we can write k final minus k initial we can say. Okay, it will become how much, k initial. So how we are going to find? Okay, so here look, there is, apart from this horizontal force, there is other two forces also there. One we can say, okay, if mass is there, okay, if mass of the block is already given, that is also 1000 kg. So mg will be downward, and due to ground surface, okay, normal will be upward we can say. But you can see throughout this motion, this normal, okay, this normal and mg will be perpendicular to the displacement, because this van is moving in the horizontal direction and force normal and mg is acting in the vertical and okay, vertical upward direction and vertical downward direction we can say. So work done by this normal force and mg force will become 0. Why? Because force and displacement are perpendicular to each other we can say. So after that what we can say, only force will act, that will be horizontal. This force is in the right direction and displacement also happen in the right direction. So work done by what we can say here, only force which will be responsible for moving this block, that will be this F. I am writing that is F, okay, into displacement, that is given in this case 100 meter, and here cos 0 degree I am writing. Why 0 degree? Because remember this force is also in the right direction. Okay, force is in the right direction as well as displacement is also in the right direction, so angle between them is 0 degree we can say. So work done by here, okay, work done by, if I will write this force is this one, and work done by if you want to write, okay, I will take, let me, okay, already I had also discussed this thing in the last class, okay, work done by normal, and here work done by mg. Okay, if I will take work done by mg, both will become 0. Why? Because theta is in this case it is 90 degree. Okay, so work done is only what we can say, it will be done by the only this external force, and that force is what we can say, it will come F into S we can say. So let's start work energy theorem. Okay, so W equals to what we can say here, it will be final kinetic energy Kf minus K initial we can say. Now final kinetic energy what we can say, half mv final square minus half mv initial square we can say. Now what we can say, if I want to substitute this one, 1 by 2 into mass we can take common, okay, and this one what we can say, v final square minus v initial square we can say. Okay, now let's substitute everything. What we can say, it is half we can write, and mass is how much given, it is given 1000 kg. Final square, final speed is how much we got, that is you can see here it is 10. Okay, so 10 square if you write, it will give you 100 minus 0 we can say. So from here if you will substitute, okay, so this is what we got, equals to work done, this is equals to work done, and work done is how much given, F into S we can say. Displacement is how much given, 100 meter. Okay, so let's calculate what we can say, if 100, if you will take other side, 100 minus 0, it will come 100. So this 100 and this 100 will cancel out, it will come how much only, 1000 by 2 we can say, that will become 500 Newton. Okay, it will become how much, 500 Newtons we can say. So this will be the force, okay, which will be responsible for moving this van from 0 to what we can say, 36 km/h in the distance of 100 meter we can say. So this was the first question. Okay, let's move to the next one. Okay, okay, so after first question, let's start the discussion of second question itself. Okay, so what it is given, if a body loses half of its velocity, remember it is loses how much, half of its velocity on penetrating 3 centimeter. Okay, this is like a block is there, okay, and it move inside the block in the first time how much, 3 centimeter, and in that process how much velocity it has lost, half of it, okay, in a wooden block. Then how much will it penetrate before coming to rest we can say. Okay, so before coming to rest, in the remaining half velocity, how much it will move inside, it is given. Okay, so they are asking how much distance it will further move inside the block with the remaining half of the velocity itself we can say. So look here again what we can say, okay, how we can identify the question. You can see by assuming that the force exerted by the wooden block, that is throughout the motion, okay, means from a starting of the penetration to finally coming to a stop, it is uniform in nature we can say. Okay, so that wooden block what it will do, it will provide one retarding type of force on the what we can say, body we can say. Okay, it is given a body losses half of its kind of, okay, half of its velocity. So how much we can say, this question we are going to solve in two part. Okay, in the two part means first initial velocity I have assumed that. Okay, so let me start with the 2 point. Okay, just 1 second. So let me take the pen. Okay, so case 1 we are saying, okay, case 1 means initial velocity. Okay, v initial I am assuming that is something v itself I am taking. Okay, in the case 1 case I am taking, first case means first we are assuming from v to half of that. Okay, v finally it become in this case, that is I am writing how much, v by 2 we can say. Okay, this is initial velocity, this is final velocity. In that case how much it has penetrated, 3 centimeter. Okay, so let's find, okay, what we can say, assuming that the wooden block is exerting constant force. So if I will write force into displacement, that is what we can say, work done by force, we can say, okay, work done by force, and this force will be exerted by a wooden block on this body. So force into displacement will be what we can say, change in kinetic energy, half m, okay, half m v final square minus half m v initial square, we can say. Okay, so what we can say here, if I'm writing f into displacement in the first case, how much given, okay, it is given 3 centimeters. So we can write also 0.03, we can say half into mass, okay, I'm taking outside v final, it is given how much it will come, it will come v square by 4, we can say. I have already done v square, 2 square, 4 it will come, and v initial will come v square itself. So force into displacement, here if you write force into displacement, how much it is going to become, okay, this value if I will subtract, how much it is going to give you, it will give you minus 3 mv square by 8, it will give you, okay, if you will subtract this one, minus 3 by 4 it will give you. So this is the first case. In the first case, this was the work done we got, okay. So let's discuss the case 2, okay. Case 2 means when particle velocity, okay, for the case 2 what we can say, initial velocity, okay, if I am observing after the penetration of 3 centimeters, so in that case initial velocity will come how much, v by 2, means after we are observing this motion, okay, after penetrating 3 centimeter I am observing this motion, that velocity will be how much, v by 2, and in this case final velocity will become how much, 0, before coming to rest, we can say. So in this case what we can say, we are, remember we are assuming that force is throughout the motion is constant. So f into, okay, in the second case displacement I am writing for a moment s naught, okay, to avoid the confusion, this s is f into s naught equals to what we can say, again we can use work energy theorem, force into displacement equals to change in kinetic energy, that is delta k, okay, that is half m v final square minus half m v initial square, we can say. So what we can say, 1 by 2 into m, here final velocity in this case will come how much, case 2 case, okay, it will become 0, and initial velocity in this case will come v square by 4, we can say. Okay, so if I will substitute this one, how much we are going to get, minus v, okay, sorry, m v square by, it will become 8, we can say. This is second equation, we can say. So look here, in this case what we are interested, we are not interested in force, we are interested in how much displacement in the second case it will travel before coming to rest itself. So what we can say, from, okay, from equation, okay, equation 1 by equation 2, if I will take, okay, equation 1, so f into, okay, f into 0.03, if I will take f into 0, okay, into 0.03 by how much we can say, f into s naught, we can say, right side how much it will come, minus 3 m v square by what we can say, 8 we can write, and this one if I will write, it will come minus m v square by 8. What was the denominator, it will go in the, okay, what was in the denominator, it will go into numerator. So this 8 will cancel out, okay, mv square will cancel out, minus will also cancel out, so it will become how much, 3 itself. So from here what we can say, this f will also get cancelled out. So if you want to find the value of s naught, so what we can do, cross multiplication you can do, s naught will become how much, 0.03 by 3, it will come, that will become how much, 0.01 meter, we can say, or we can also say 1 centimeter will become your final answer itself, we can say. Okay, so this was the, okay, so in the second case, after penetrating 3 centimeter with the latter half of the velocity, it will move how much distance, that will be equals to 1 centimeter, we can say. It will become how much, 1 centimeter, we can say. So let's move to the next question then. Okay, so in this question what we can say, okay, you can take a look here. A particle of mass small m moves along a straight line with its velocity varying with distance. Look, it is just slightly more level, we can say. If out of the 10, okay, if you, in the work energy theorem, out of the 10 level, if I will divide, okay, 0 to level 10, okay, so I will give you this question 6, okay, 6, okay, it is slightly more than average, we can say. Okay, so a particle of mass small m moves along a straight line with its velocity varying with the distance. According to equation what given, v equals to c into a square root of x, we can say. We remember x is nothing but it is distance from certain reference point there, or origin, we can say, where c is a given, this c is given constant. Find the work done by all the forces during the displacement of x equals to 0 to x equals to s is given. So look, this question we can solve using two methods. Okay, two method means if you know work energy theorem, then the solving this question will become really easy. Why? Because we know, okay, they have asked here what work done by all the forces, and we know from the work energy theorem. Okay, if I'm using work energy theorem, okay, suppose if I'm using work energy theorem, okay, then in that case work done by all the forces, if I will write, okay, all the forces, okay, that is already we know that will equals to directly what we can say delta k, we can say delta k means k final minus k initial. And to write final kinetic energy, what we have to do, simply we have to substitute what will be value of final speed we need, mass is already given, what will be final speed and what will be initial. One time we got that answer. So what we can say in this case, if I will write half into m, okay, m I am taking common because that is constant for initial and final, we can say final speed square. Okay, so here final means what, final speed will be when particle will be at x equals to s. So if I am writing for a moment, final speed will come how much, when x equals to, it will come s, so it will come c into a square root of s, it will come, and v initial will come how much, x equals to 0 if you will take, so c into 0, it will give you 0 itself. So half m final square, so it will come c square into s minus initial is 0, so it will come how much, m c square s by 2, we can say. So this will be the answer of your question, we can say. This will be answer of your question if you know work energy theorem. If you don't know work energy theorem, there is a also alternative method is there. Okay, in that case it will be little bit lengthy, you have to use differentiation. Why? Because work already know. Okay, if force is, okay, so here first to calculate the work you have to calculate acceleration. How we are going to do, here velocity depending upon x, so in that case acceleration if you want to calculate, so it will come v into dv by dx. First you have to calculate acceleration and then after that you have to perform integration. Okay, because here if you, okay, let me just help you how we are going to get that answer. Okay, so here if velocity is what we can say c root x, we can say, and differentiation of c root x will come how much, c is constant, so we will keep outside, and differentiation of root x will come 1 by 2 root x, we can say. So this root x will cancel out, it will become how much, c by, okay, c square by how much, we can say, it will become 2. So you can see this acceleration we got, that is constant in nature. Okay, so in that case what we can say, first you have to calculate force. Okay, net force equals to what we can say, mass into net acceleration. Okay, already know from the Newton's second law, it will come how much, mc square by 2, we can say. Okay, so you have to use differentiation in this case, as what we can see is constant, mass is constant, 2 is constant, so force is constant, so you can use work by all the forces. Okay, all the forces. Okay, so what we can see, it will come net forces acting on the body, that is mc square by 2. Okay, and just one second. Okay, let me just do. Okay, so here work done by all the forces. Okay, so work done formula already know, F into S, we can say force into displacement, and force is positive as well as particle also move in the right direction, so angle between them will become 0. So force how much, we can say, here is given, that is given m c square by 2, and displacement how much given, final is S, initial is 0, so we can directly write S itself, so it will come also mc square S by 2, we can say. So both method you can solve. Okay, both method you can use to get the answer will not change, this one and this one, both the answer are same. We can, this answer and this answer both are same, we can say. You can see here both answer are same, but only in this case what happened, you have to use differentiation to get that answer, you can see. Okay, it is very useful. Okay, especially in the mains and NEET, this kind of question nowadays they may ask itself.